Now we're going to look at two other types of loops in Java and also two statements that can be used to control execution within a loop. So the first example of a type of loop, a new type of loop we're going to look at, is a for loop. Remember before we did a do while and it gave an initial test condition. Okay, so anytime you have a loop, you have to have an initial condition and some kind of initializer. It usually was I equal to 0 or maybe I started at 10. You have a test condition. For example, in BlastOff, I started with, say, n equals 3. I had a test condition. Did I get to 0 yet? And then my test variable update for BlastOff, I was decrementing each time. I was subtracting 1 from my test variable. So you're always going to need an initialization, a test condition, and a test variable update. And the for loop allows you to do that more concisely. So what's happening here is the for loop always has this format. The word for, and in parentheses, this first statement here is the initializer. This variable I is what I'm going to be using when I'm iterating through the loop. That's my variable that I'm using for the test condition. Now I started at 1. As long as I is less than the number of rows, whatever rows is, okay, I guess that was passed in. So as long as that's true, I will execute the body of the loop. I will print out the row, go back up here. When I'm done with the body of the loop, when I'm done with the last statement, go back up here. But I don't execute this anymore. I will always execute this update condition or this update statement when I iterate back to the top of the loop. So the first time I go through the loop, I is 1. I test it. I go back up here. I test it. Actually, first I have to increment first, and then I test it. And if it's still true, if this is still true, this condition, then I go through and do it again. Okay, I get to the bottom of the loop, I increment I test it. As long as it's true, I keep doing that. And again, we're hoping that there's going to be a condition where it will terminate. So as it says here, anytime you have a for loop, the initializer is run only once at the beginning of the execution of the loop. The test condition is checked each time you go through the loop, and the update is done right before you loop back to the beginning. So at the beginning of each iteration, after the first one, this update will be done. Okay, another thing to keep in mind, notice how here I have int I equals 1. I actually declared I right here in the initialization section. If I do that, if I'm declaring it right in there, I cannot use I outside of this loop. If I want to use I outside of the loop, I have to declare it outside of the loop. But if it's declared here, if I'm only going to use that as an index in my loop, it makes sense to declare it in here. Then I don't have to worry about causing problems with it because it's only used in here. I can't access it anywhere else. There's another type of loop called a do while loop. Okay, this is called a post-test loop, meaning the test condition is done at the end of the loop. So the two we looked at previously, the for loop and the while loop, the test condition is always executed at the beginning of the loop. Remember when I got into the for loop, I started with I checked to see if I is less than or equal to the number of rows. If so, then I can execute that. That was true for the while loop as well. It may say while I is less than or equal to number of rows, it will execute it. So it always tests at the beginning. However, the do while loop tests the condition at the end of the loop. It'll always execute the loop at least once. And that's when the do while loop actually is useful, when you do need the loop to be executed at least once. One example of that is for reading input. Maybe you want to read input until you come to something that's either invalid or valid, and we'll look at an example of that later in this lesson. Okay, there's two statements that you can use to change the execution or the flow of execution within a loop. Remember, the body of the loop is always executed sequentially, and it keeps going till it hits the final brace, the end of the body of the loop, and continues. There may be cases where you want to stop execution in the middle of a loop and just exit. That's what the break statement is for. Wherever you are in the loop, if you hit a break, you want to exit. That may be true if you're trying to do some kind of operation and maybe you hit an error message. You want to break out of the loop. You don't want to continue. There's a continue statement where you could be going along in the loop and maybe you hit a point where you don't want to continue the rest of the loop. Again, it could be a case where something that you're doing is invalid and you want to maybe prompt the user for something new. That's one example. The continue statement causes the loop flow of execution to move on to the next iteration. So instead of going to the bottom of the loop, it would jump back up to the top from the continue statement and continue the next iteration of the loop. We'll look at two examples. We'll look at a couple of examples of the break and continue statement. And the examples we look at will help them to become more clear. So the first example we'll look at is an example of the do while loop. Remember, this always executes the body of the loop at least one time, and then it continues back to the beginning. It will test before it continues back to the beginning. Before it does the second iteration, it will test the test condition. And again, one example we gave for this, use for this was when you're entering input. You want to validate that it's a reasonable input. So in this case, we're prompting the user to enter a number. So we want to make sure they did enter a number. So what we're going to do is we prompt them to enter a number. They enter it. We're going to check if it's a double. Did they enter a double? Maybe they entered some characters. Maybe they entered a word. If they entered a double, true, we're good. If they entered something else, then we're not good. We're false. Okay, so what we're going to do then is output that this word is not a number. This input you just typed in is not a number. Now remember, even though it's not an input, even though it's not a double, we still have to actually read it in. Has next double only checks to see what the next input is. We don't actually put it anywhere. And so since we decided it wasn't a double, we have to get rid of it. We have to read it in, throw it in here. We're not going to do anything with it. We're going to just say, this thing you just gave me is not a number. Okay, now this looks a little strange because it says, do this while everything's not okay. It feels like you want to do everything while it is okay, but remember, we're testing the validation of input. So if okay was true, then we're good. We don't have to keep prompting the user for good good input, because we know they just gave us a double, which is what we wanted. So as soon as they give us a double, okay is true, not okay would be false, so we do not need to continue going through this loop because they gave us the correct double. Now what if they didn't give us a double? Then okay is false. If okay is false, we want to continue prompting them for another number. We want to stay in the loop if okay is false. So we want to do this while not okay, meaning if okay is false, not okay would be true. We want to continue this as long as they're giving us bad input. We want to keep prompting. As soon as we're done with this loop, as soon as we've checked that has next double, shows us that there is a double in the input stream, that's the next thing we'll read in, then we can go ahead and read it in. We know we safely have a double, what we expected, and we return it. Now this function, scan double to, does something different, but it does it in a different way. It does the while loop that tests at the beginning. Remember, a pre-test versus a post-test. The do while does the post-test, tests at the bottom. This one tests at the beginning. So while true, we want to keep executing this loop. Now generally you don't want to put a while true in there because that condition will always be true because true is true. It looks like we're setting ourselves up for an endless loop. However, that's the use of the break statement. So what's going to happen here? Oh, by the way, I wanted to mention we have to remember to put in java.util.scanner. And again, we set up the scanner at the beginning. So anyway, that I think you know already, but just to review. Okay, so while it's true, I want to prompt the user for a number. So I print out enter a number. I check to see if the next thing in the input stream is a double, which is what I want. If it is a double, break, get out of this loop, go down here. If it's not a double, I want to read in that number and print out that, oh, you just gave me something that's not a number. I don't want it. I go back to the beginning of the loop. Well, true is still true. I prompt the user to enter another number. I check if it's a double and so on. So the only way I'm getting out of this loop is as soon as the next input number is a double, I break and I go down here, read it in, return the double. And the final example we have, this is also a pre-test. While the number is not equal to 0, I'm going to read in numbers. If the number is negative or if the number is 0, I do not continue in the body of the loop. Remember, the body of the loop starts here and ends here. So if the number is negative or 0, I go up to the top of the body of the loop. If the number was 0, I'm done with the loop. That's when I'm done adding up the numbers. If the number was negative, I basically skip it. So I only want to add together positive numbers. So I read in the integer that the person gives. If it's valid, I add it. Okay, I'm adding to the sum. Remember, the sum started as 0. This plus Equals, remember that's the same as saying sum equals sum plus x. That's a shorthand. So what I'll do is the next number I read in, add it to sum, go back to the beginning of the loop. If x is, as long as x is not equal to 0, which it wasn't because I got down here, I do the same thing again. As soon as I hit a 0, I'll continue. It'll put me here. If it's a 0, I stop adding. If it's a negative, I go here and I just ignore it. So let's see what happens when we run these couple. Remember, the first one I'm prompting until I get a double. The second one does the same thing. The second one does the same thing, but remember it did it with a pre-test instead of a post-test. And the third case is just adding numbers until I hit a 0 where it'll stop summing, or if I throw in negatives, it should ignore them. So let's see what happens when we run it. Okay, so I'm in scan double. It wants me to enter a number. I'll try a number that's bad. Oh, that's not a double. It tells me it's not a number. So that's a little bit messed up where this put out, but it wants me to enter another number. Let's enter 29. Okay, it got a good number, 29, it's done. Scan double 2 does the same thing, but remember it does a pre-test instead of a post-test. So I'll type in my number. It's good, I'm done. Now I'm going to add some numbers. Let's give it a number to add. 5. I'm adding 5. 4. I'm adding 4. How about negative 2? It just basically should ignore it. How about 0? I'm done. So the sum is 9. The only two it took into account here was the 5 and the 4. It added them, and it looks correct.